Yes.
I think I spotted a weakness in your cosmological argument.
All right.
And that's that you have defined infinite as something that can't be counted. And yet, when you try to apply infinite, such as deducting every number after 3, and explaining that as an infinite, that, I mean, these are different infinites that you're talking about.
Yes.
And they're not really measurable. The only way that you... the only way that you could do this is by matching different infinites.
I don't think I did define the infinite as something that's not countable. In fact, quite the contrary. In set theory, sets which have an actually infinite number of members that can be put in a one-to-one relationship with the natural numbers are countable. It's called a denumerable infinite. Now, there are infinite quantities that are even bigger than that, and they're called non-denumerable infinites. Those are truly uncountable. But all I'm talking about tonight are denumerable infinites, infinites that would be would be a collection that has the same number of members in it that the series of natural numbers does. So we don't even need to talk about non-denumerable infinites tonight. I don't think that that even comes into play. So it doesn't seem to me that what I've said tonight depends upon that concept of the infinite that you mentioned.
I think that you have a problem with saying that there is a countable infinite and a non-countable infinite, in that there is a countable infinite, but you can't count them.
Certainly, I couldn't count it physically. That's right, because I would die before I could count all the natural numbers. But that's just not any part of the argument. The part of the argument had to do with subtracting identical quantities from identical quantities and coming up with non-identical results. And that's why in transfinite arithmetic, the subtraction and division with infinite quantities is prohibited, because you get self-contradictory results. You don't get any sort of consistent answer. But the difficulty is, in reality, you can do that. If I had an infinite number of coins, I could take away some of them. So it seems to me that this illustrates very powerfully that, in fact, infinity is a legitimate, consistent concept, given its rules, for use in mathematics, but that it can't be put into the real world. You can talk about it on paper, but you can't translate it into reality, a reality of coins and beads and seeds and people and things of that sort.